Okay, here's another example, and since we've already gone over all the techniques, it should be a little bit faster on this one. So we want to graph this, find the vertex and graph it using the standard form. So let's start with the vertex, and we know that the x value of the vertex, x equals minus b all over 2a. And we look at our equation, and we know that we have negative 1 is a, 6 is b, and negative 5 is c. Also, since the a is negative, we know it's going to be shaped like an n for negative. So when it comes to this, we will be able to determine that it's got a maximum, not a minimum. So I just substitute my values in. So I've got minus b, so it's going to be negative 6 all over 2 times, and a is negative 1. Substitute carefully, and I've got negative 6 divided by negative 2. So that means the x value of my vertex will be 3. Okay. So my vertex will be the point 3 something, or 3f of 3. This is x, and this is the y. And remember, the y is going to be this. So my y will equal negative something squared plus 6 times that something minus 5. This should be in red so we can show our substitution. So this is the x value, and I put the x value in the y. This gives me the y, whatever that is. 3. And 3 squared is 9, so I've got negative 9. 6 times 3 is 18, and minus 5. So negative 9 and negative 5 is negative 14, plus 18 is positive 4. So that's my y-coordinate for the vertex, 3, 4. Okay? So there's my vertex. I know my axis of symmetry is going to be x equals 3. And since this is shaped like an n, I have a maximum, so my maximum will be y equals 4. Okay? So far, so good. And then we can always find the y-intercept. Remember, that's when x is equal to 0. What's y? And if I put 0 in here for x, either one of these, I get 0, 0, negative 5. So the y-intercept is negative 5, or 0, negative 5. And we should be able to graph a bit with this. Let's find our x-intercepts. We can do that. We know the x-intercepts would be when y is equal to 0. So we can say negative x squared plus 6x minus 5 equals 0. In other words, we say we want this to be 0. Now, when we're solving this quadratic equation, we're not dealing with the shape, so you can change all these signs and divide everything by a negative 1 every term. And it's going to still give you the same zeros. Now, it's going to flip the equation, but it will still have the same 0. In other words, want to go like this, want to go like that, but they're both going to have the same 0. So, but this new equation is the one we're graphing the original one, so keep that in mind. But to solve this quadratic, it's a lot easier to have a positive sign in front of the x squared. So we have x squared negative 6x plus 5 equals 0, and that's a lot easier to factor. So we know we're going to have x's and x's. This tells me these signs are the same. If they're the same, this tells me what they are. They're negative 6. I'm sorry, they're the same, so they're both negative, pardon me. If it's positive, this tells me the signs are the same. If they're the same, this tells me what they are. And they have to multiply to give 5, and the sum, same in sum must be 6, so that would be what? Multiply to give 5, and the sum is 6. 2 and 3. Oh, I'm sorry, multiply to get 5. Not 6. So multiply to get 5. So there's only one way I can get 5 is 5 and 1. There we go. Okay? Pardon me. I was looking at the wrong number. Okay? All right, so they have to multiply to get 5. And their sum has got to be 6. So I know I've got x minus 5. Oops, sorry, don't need that. Equals 0, or x minus 1 equals 0. X equals 5, or x equals 1. So my intercepts are going to be 5, 0, or 1, 0. So now we should be able to get a pretty good graph pretty fast, okay? So let's take a look at this. So we got all of our data here. So I'm going to transfer this over to my graph. Okay. So my vertex was what? 3, 4. So 1, 2, 3 up 4. 1, 2, 3, 4. So there's my vertex. I can label it 3, 4. Okay. My axis of symmetry, that's important, was the line x equals 3. Vertical line. So I'll dash that. It's shaped like an N, so I'm going to go down. I'm not going to have anything above it. So there's my dashed line. There's my axis of symmetry. And my y-intercept. My y-intercept was a negative 5. So that's 0, negative 5. So I got a point here, 0, negative 5. So I'll put a point there. And that's my y-intercept. 0, negative 5. Now notice that this is 1, 2, 3 units to the left of the axis of symmetry, so that means I've got another point exactly across, 3 units to the right. So I go 1, 2, 3, and this is my other symmetry point that I get from my y-intercept. I can find the point, the actual value is 6, negative 5, but you can see that. This is we got it from our y-intercept. Don't really need to label that, okay? And then we also have our x-intercepts, and those are going to be the points 5, 0, and 1, 0. So here's 1, 0, 1, 0, and here's 5, 0. And you can always check these. They should be both the same distance from the axis of symmetry, and this is 1, 2 units to the left, and this is 1, 2 units to the right, so we're in business. Looks like we did it. Is that correct? And this is the point 5, 0, and the point 1, 0. And now we've got it. We've got our 5 points. And that's usually what we like when we graph a parabola. Try to make this almost like a little bowl in the bottom, or like the nose cone of a rocket. Make it rounded. And bring it right down. And there we go. Now we've got, I think we've answered all the questions on our sheet. We've got the vertex, axis symmetry, maximum value. Okay, y-intercept, x-intercepts, so everything's there. And the last thing would be the domain and the range. And remember, the domain on these are always going to be negative infinity to positive infinity. It's going to go out. We can put these values over here if you want. This is going to be the value. This is going, x is going to negative infinity, and then y is going to go to the negative infinity because it's going down. And over here, x is going to positive infinity, and y is going to negative infinity because it's going down. So you can look at those extreme values also. So the domain is always going to be the x extremes, negative infinity to positive infinity. So that's easy. And that's open. Infinities are always open. And the range will be the y values. Now notice now I'm going up to 4, but my left extreme is negative infinity. So I'm going from negative infinity up to 4. So in this case, the range is going to go from negative infinity, and it's going to go up to and including 4, the y value. And there you go. So there's your domain and range. Let me move this over a little bit. And now you got it. And the arithmetic is pretty easy on these first examples, just so you get the idea. We could try something with a little more challenging arithmetic later. So there you have it. So go back and review. If you get those two examples down, you should have no trouble doing the homework.